Hello everyone. Welcome to the solution of LeetCode problem 2492 named minimum score of a path between two cities. In this problem, you are given a positive integer n representing n cities numbered from 1 to n. And you are also given a two-directional or two-dimensional array rows where the row of I contains three values, which is a, b, and distance. Indicate that there is a bidirectional road between the cities A and B with a distance equal to the distance. And the cities graph is not necessarily be connected. Now, the score of a path between two cities is defined as the minimum distance of a road in the path. Now, we have to return the minimum possible score of a path between the cities 1 and n. Now, we have to make sure, or we have to keep in mind, is that a path is a sequence of roads between two cities. It is allowed for a path to contain the same road multiple times, and you can visit cities 1 and n multiple times along the path. And the test cases are generated in such a way that there is at least one path between 1 and n. Now let's consider the first example. The city 1 is connected to 4 and 2. 4 and 2 also connected, and 2 and 5 also, 2 and 3 also connected. Now, the cost or the weight between 1 and 4 is 7, 1 and 2 is 9, 4 and 2 is 5, and 2 and 3 is 6. So here, we have to find the minimum distance between the node 1 and 4. So, if we come into this direction from 1 to then 2, 4, the distance will be minimum of 5 and 9. It will be 5. And if we come 4 from 1 to 4, the distance will be 7. So what is the minimum of these two distances? It will be minimum of 7 and 5. That means by using the distance 5, we can reach to the node 4 from the node 1. It is the minimum score. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken this example. Now, here, our source is 1 and our destination is 4. Now, let's see in how many ways we can reach from 1 to 4. The first way is we can reach 1 to 4 directly. The second way is we can reach 1 to 2, then 2 to 4. In the first way, the cost will be, or the score will be 6. In the second way, the score will be minimum of 7 and 8. It will be 7. And in the third way, it is we can reach from 1 to 2, then 2 to 3, then again 3 to 2, then again 2 to 4. So here the cost will be minimum of 7, 4, and 8. It will be 4. So the optimal strategy to reach the node 4 from node 1 is following this path. So here the minimum cost will be 4. So we have to return it. Now the question is, how can we solve this problem? In the question, we have mentioned then there is at least one path from source to the destination, or there is at least one path between the node 1 and 4. So the intuition is very simple. If there is a path between 1 and 4, that means this definitely having a component, connected component. So we have to simply find what is the minimum cost of a path in this connected component, and we have to return this as answer. Why this solution works? Suppose in this problem the minimum is 4. So here, as this is a connected component, that means there should definitely a path from source to destination where the path or the road between 2 and 3 will be available. That means we can reach 1 to 2, then 2 to 3, then 3 to 2, then 2 to 4. So we have to always find the minimum cost of a connected component, and this will be our desired output. And to find the connected components minimum cost, we can use DFS, we can use BFS. Anyways, in the coding section, I will use BFS for the simplicity. I hope you understood the intuition behind the solution. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named mean score, which is integer n, and the vector of rows. Now, we are taking our adjacency list, which is a vector of pair. Now, for each of the rows, we are inserting the pair v and weight to the adjacency list of u, and we are inserting the pair u and w in the adjacency list of v. Now, we have to declare a queue, and we are taking a visited array, and we are inserting 1 to the queue and making the visited array of the index 1 true. And currently, our minimum age will be integer maximum. Now, this is the BFS while the queue is not empty. We are inserting the font element of the queue into a variable node, and we are removing it from the queue. Now we have to iterate each of the adjacency list element of this current node, and here the neighbor will be iterator first and the weight will be iterator second, and the minimum age will be the minimum of minimum age and the weight. Now if the current neighbor is not visited, we have to mark it visited and insert the neighbor into the queue for the next iteration. Finally, we have to return the minimum age as the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.